Hey, welcome to your next algebra lesson. I'm going to try to get through this as fast as possible, but there's a lot to talk about. This is Unit 6, Lesson 9, so that means we've skipped over a few lessons. Now that we're in our version of remote learning, I'm going to not be teaching every lesson in every unit. I'm going to try to hit the most important things. The name of the lesson is actually called Radicals, but for our purposes today, really what that means to you is square roots and cube roots. So let's remember what a few things are. For example, what is a square root or what is a radical? This is a radical symbol, right? Oops, you can't see it. There it is. And that means square root, right? So if I put a number inside here, such as 25, you're trying to find the square root of 25. And what that really means, real quick, crash course in remembering how to do square root. You're looking for the number that when you multiply it by itself, you get 25, right? So we're looking for the same factor. And it happens to be 5 times 5. So the square root of 25 is 5. So that's what square roots are. Square roots are when you're looking for 2 of the same number multiplied together. Then there's this called a cube root. Its symbol looks like this, similar, but it has a little 3 hiding up here, kind of like an exponent, but not really like an exponent. Cube root means what number times itself again would equal the number that you see in the expression. So can you think of what number times itself again would equal 8? Happens to be a 2. 2 times 2 times 2 is 8, right? 2 to the third power is 8. So square roots are when you're looking for 2's, and cube roots is when you're looking for 3 of them at the same time. So now let me talk to you a little bit about your calculator. You're going to want a calculator for these notes. You're going to want a calculator for the homework problems. And specifically, all calculators are a little bit different. Here's a calculator. You might have this one. I know it's a little hard to see. It's almost like let me see if it's better if I turn the light off. No, that actually is pretty much terrible. I know there's a glare, but if you look above in this calculator, above the x squared button, up here, really light in this light blue, that is the square root button. So if we wanted to find the square root of a number, you would, I believe, you do the second function, and you would hit that, and you would put in the number you were trying to find the square root of. There we go. And then you could hit enter, and it would tell you the square root of 25 is 5. So it kind of gives you the square root symbol. Now, what if you want to do cube root of a number using a calculator? Well, that's a different button. And then this calculator, it happens to be right here above the caret button. And I know it's super difficult to see, but it's right there. And here's what that symbol says. It's the radical with an x, and that means I can find any root of a number. I could find the cube root or the 4th root or the 5th root or the 6th root. So if I wanted to do that on this calculator, if I wanted it to do cube root, you have to put in this case, a 3, then second function, then that one that has a little x up there, so it's this one. See, there it is. And now I'm going to put an 8. I know it's so hard because it's blurry. It'll adjust. Enter. And there it is too. So you're going to just have to play with your calculator a little bit and kind of see what steps need to be taken in order to get your calculator to do square root and cube root. All right? That's how you do it for this calculator. Now I'm going to show you other ways to do this where perhaps you won't even need a calculator, and that would be ideal, wouldn't it? Awesome. Okay, so square roots and cube roots. Here we go. Radicals. What is the definition of a radical? It is an expression with a symbol. That's a radical symbol. And again, written this way right now, that means square root. That's what this says. That's the square root symbol. We're also going to today, I've already told you all this, right? We're going to talk about cube roots. So there's actually a little 3 right there. There's something called 4th root and 5th root and 6th root, and you could keep going. But essentially, these first 2 are the 2 that we're most concerned with. So we're simply going to focus on square roots and cube roots. Okay, let's practice some of these. So there's a couple ways you can do it. Like I said, you could use a calculator. Nothing wrong with that. Or you can use your brain as much as possible. But if not, break out that calculator. And in fact, on some of these, we may have to do that. You know, if numbers get big, like 484 or 324, you may not know what number times itself is 324. In that case, we'll use a calculator. I bet you know the first one. I bet you can tell me what the square root of 4 is, right? What number times itself is 4? Of course, that's a 2. That one's nice and easy. Guessing you probably know the square root of 81. What number times itself is 81? That's 9. Because 81 is a perfect square. These are called perfect squares, these numbers in here. So 9 times 9. So the answer is just 9. Don't write your answer as like 9 squared. That's not right. Don't do that. It's just 9. The square root of 81 is 9. Anybody know the square root of 256? Do you know what number times itself is 256? 16 times 16. So the square root of 256 is 16. Let's see. Let's do 484. I'm assuming you don't know it. So I'm going to do the square root of 484. I'm going to do second function, square root symbol, 484, 22. Awesome. So 22 times 22 is 484. So the square root of 484 is 22. That's pretty cool, right? All right. Hey, what's the square root of 1? What times itself is 1? That one's easy. It's 1. What about when we have a fraction? Like we do on, let's say, number 10. Here's how I think of these. I basically take that radical symbol and I break it into the numerator and the denominator. So it's almost like you're solving 2 separate problems. Square root of 1 is 1. Square root of 16, it's not 8. You can't think that it's divided by 2 because it's not. Remember, you always have to think, what number to the second power is 16? Or what number times itself is 16? And it's 4. So the square root of 1/16 is 1/4. Right? So now you could probably do it here pretty easily. The square root of 9 over the square root of 100. 3/10. That's not too bad, right? Okay, but let me give you a little bit of a heads up about square roots. So I'm going to go back up here and we're going to write something kind of important. Even though it's not on these notes, I do want to talk about it. What about a situation like this? Can I take the square root of a negative number? No. The answer is no, you can't. Because no number times itself will ever be -4. And maybe some of you are thinking, well, what about -2? No, that's not going to work. Because -2 times -2 is +4. So you can't do it. You cannot take the square root of a negative number. No solution. Null set, empty set, not possible. Call it whatever you want. It can't be done. So for square roots, you cannot have a negative number in there. That's not going to work. All right, let's talk about cube roots. Same thing as square roots, except now instead of what number times itself, we're talking what number times itself again, right? We want it the number 3 times. So I know it's really difficult to see, but this says, let me move that out of the way, sorry. This says, what is the cube root of 8? Well, we already know because I did this one as an example. So what number times itself again equals 8. And it's 2 times 2 times 2. So the cube root of 8 is 2, final answer. And again, if you finagle around in your calculator, you'll probably, hopefully you can get it to work. Oh, look at number 14. Can you read what that says? It says the cube root of negative 125. Guess what? You can take the cube root of a negative number because a negative times a negative times another negative equals a negative number. So this one you can take the cube root of. So we're going to write a little note to ourselves up here that says the cube root of, say, negative 8 can be done. And it happens to be a negative 2 in that example up there. So that one can be done. There you go. All right, so back to number 14 here. What number times what number times what number, all the same number, multiplied 3 times, would equal negative 125? Negative 5, and negative 5, and negative 5. So the cube root of negative 125 is negative 5. Right? Negative times negative is positive, times negative again is negative. See, it works. Very good. Let's see. Let's do this one. That's a huge number. The cube root of 4,096. Guess what? You probably do not know what number times itself again is 4,096. Guess what? I don't even know that, and I'm a math teacher. So I'm going to put it in my calculator. I'm going to do the cube root of 4096. Awesome. 16. Boom. So it's 16s all the way across. Final answer of 16. All right? Let's do one more. Let's do this guy down here. It says cube root of negative 27. Yes, you can take the cube root of a negative. So what times itself is negative 27. Negative 3. That makes negative 9. That makes positive 9, sorry, and that makes negative 27. So the cube root is negative 3. All right? Okay, guess what? That's only just the beginning. Now we're going to dial it up a notch. We're going to take these same ideas of square roots and cube roots, and we're going to start using those ideas and explore numbers that are not perfect. So what I mean by that is these are all numbers that when you take the square root of, you get a nice, pretty little answer. Or if you take the cube root of, you get a nice, pretty little answer. These are called perfect squares. Like 36 is a perfect square. 1 is a perfect square. 121 is a perfect square. And then down here, these numbers are perfect cubes, right? These are nice little perfect cubes, and you can take the cube root and you get a nice little answer. But what if I have numbers that are under the radical sign that are not perfect squares or not perfect cubes? Well, then it gets a little tricky. So let's talk about non-perfect square roots. It says use the perfect square numbers below to break the problem apart. So let me give you the first few perfect squares. So what we're asking, or what we're going to list here is, what is 1 squared? 1. What is 2 squared? 4. And 3 squared is 9. And 4 squared is 16. And 5 squared is 25. And 6 squared is 36. And 7 squared, 49. And then 64. And then 81. And then 100. And we could keep going and keep going and keep going. So if you are good at memorizing the first, ideally probably 15 perfect squares, these special numbers here, these perfect squares, that's going to help you in the problems that we're going to work on next. Or you can also do something called prime factoring. We haven't done prime factoring in a long time, but I'll review it with you quickly. It's not too bad. Okay, check it out. So we look at 24 and you're thinking, gosh, what number times itself is 24? Ew, there isn't one. And don't say 12 because it's not 12. I'm going to show you two ways to solve this problem. First thing you could do is you could look up here at your list of perfect squares and see if any of these are a factor of 24. In other words, can I take any of these perfect squares and multiply them by any other number, doesn't have to be a perfect square, to get 24? The answer is yes, because 4 is a factor of 24. So check out, this is what you can do. You can break 24 apart into a 4 and a 6, right? 4 times 6 is 24. So you would take the square root of that times the square root of that, right? And guess what? You're only going to actually solve the radicals, the ones that are perfect squares. So what's the square root of 4? You can tell me the square root of 4. You better be able to. And it's 2. But the square root of 6 is not 3. It's some wonky decimal that we don't want to deal with. So if it's an ugly number in here and it's not a perfect square, like 6 is not a perfect square, you can just leave it as a radical. So you break it into two pieces. This piece you can solve, so you solve it. This piece you really cannot, so you leave it in radical form. So you're going to call this 2 square roots of 6. And that's your final answer. We'll do more, don't worry. But I also told you I was going to show you a way to use prime factoring. And that might come in handy when we get into some of these bigger numbers. Let me show you. Remember prime factoring, where you take 24 and you break it down into two numbers that multiply to get 24, like 2 and 12, right? Remember breaking numbers down? That's a dead end because that's a prime number. This one, how about 3 and 4? 3 is prime, 4 breaks down to 2 and 2. So breaking down 24, I could say the square root of 24 is the same as the square root of 2 times 2 times 2 times 3, right? 2, 2, 2, 3. So when you're finding square roots, you got to remember that square root means 2. It's like we have a little 2 sitting out there. So if you see a number that you can pair up, for example, these guys make a pair, you can, I'd say, factor out. You can factor out this. So this is really a 4, right? 2 times 2 is 4. The square root of 4 is 2. So because you see two 2's, you can pull one of them outside of your radical symbol. And what's left? A 2 and a 3. And since they don't have any buddies, they can't partner up. There's not 2 of them, so you can't factor one out. You just leave it and leave them inside, and 2 times 3 is 6. So we'll do more like that too. But whether you do it this way of prime factoring, and then you look for the partners and you circle the partners, the buddies, the pairs, and then you factor one out, just like this, because the square root of 2 2's is basically just 1 2. And then your remaining numbers just get multiplied together. So whether you do it this way and you get 2 square roots of 6, or you do it this way and you get 2 square roots of 6, the same thing. It's just different ways. Let's do it again. Let's do 48. So you can look up here and you can ask yourself, are any of these perfect squares factors of 48? And the answer is yes. Actually, there's more than one, right? You could do 4 and 12, or you could do 16 and 3, okay? Let's do 16 and 3. Right? Because 16 times 3 is 48. What's the square root of 16? 4. What's the square root of 3? I don't know, something really ugly. So you leave it as the square root of 3. 4 square roots of 3. You want to do the prime factor way? Let's do it. Let's break down 48. Where am I going to do that? Let's do it over here. Okay, so I prime factored it. So this basically means the square root of 2, 2, 2, 2. I've got 4 of them. and a 3. I'm going to look for pairs. There's a pair of 2s, so I take a 2 out. There's a pair of 2s. I'm going to take another 2 out, leaving behind a 3. So I took a 2 out and another 2 out. 2 times 2 is 4. So 4 is on the outside, and the square root of 3 is still left behind. So it's 4 square roots of 3. Right? So you took 1 2 out here and another 2 out there, and those became that 4. So prime factoring is another good way to do it. Let's do, I don't know. You want to do a big one? You want to do like 245? Let's do 245. You could look at your prime factors and go, or your perfect squares, and well, 49 happens to be a factor of 245. So this would work. You could use 49 and 5, which becomes a 7 square root of 5. I think that that's cumbersome. I think a lot of kids aren't going to know that. So again, I would take 245 and I would prime factor it. Let's do that. Uh, 245 can, oh darn the blurriness on this thing. 5 goes into 245, what, 49 times? Yeah. Oh, why? Why is it so blurry? Come on. Okay. 5 is a perfect or a prime number. It can't be broken down. 49 breaks down into 7 and 7. Now both of those are prime. So it'd be the square root of 5 and 7 and 7. And since you have a pair of 7s, you bring the 7 out, and that would leave behind the square root of 5. So that's another way to do it. I kind of like that way. All right. I know this is kind of a long video, but you know, that's all you have to do today is watch this video. I want to end with finding the cube root of numbers that are not perfect cubes. Here we go. Non-perfect cube roots. Use the perfect cube numbers below to break the problem apart. So let me tell you about perfect cubes. What is 1 to the third power? 1. What is 2 to the third power? 8. What is 3 to the third power? 27. And 4 to the third power? 64. And for 5, it's 125. And for 6, it's 216. And for 7, it's 343. So it would behoove you to write those numbers down. They may come in handy as we try some of these cube roots. And again, these are not going to be nice little easy ones. Your calculator isn't going to help you here. You're going to have to kind of do this the long way. Let's start with this one right here. Let's find the cube root of 40. So you look at your perfect cubes and you say, gosh, are any of these a factor of 40? Boom. 8 is a factor of 40. Because 8 and 5, right? So you could find the cube root of 8 and the cube root of 5. But you're only going to solve it if it can be solved easily in what I would say in a clean way, right? No decimals, nothing ugly. Can you take the cube root of 8? Yes, you can, and it's 2. Can you take the cube root of 5? Not without it being some really yucky number in decimal. So because this one doesn't tidy up to be nice and clean, you can go ahead and leave it as the cube root of 5. So we would say 2 times the cube root of 5, or 2 cube roots of 5. Right? Now let me show you how you can use prime factoring, because it works for this as well. You could take 40 and let's break 40 down. Any two numbers that multiply to get 40. I'm going to choose 4 and 10. Neither of those are prime. So I keep going until I got a list of all primes. So I've got 2 and 2 and 5 and 2, right? So I've got all my prime numbers now. Check this out. When you're doing cube roots, instead of looking for pairs of numbers, like we were looking for pairs of numbers for square roots, for cube roots, you can look for triplets. So we're going to find the cube root of 2, 2, 2, and 5. So because it's cube root, you need not a pair of numbers, but a triplet of numbers. There's a cute little triplet. 2 times 2 times 2 is 8. The cube root of 8 is 2. Another way to say it is, if you see a triplet of numbers, you get to pull one of these numbers out. So what comes out? A 2, leaving behind the cube root of 5. So 2 cube roots of 5 or 2 cube roots of 5. Okay, let's just do like 2 more, okay? I don't know. I can't decide which ones we want to do. Let's do, I don't know. Let's do, I want to do a negative. Sorry, you're like, make your mind up, Lesnar. Can we do cube roots of negative numbers? Yes, we can. So let's look up again at our list. Where'd my list go? It's so difficult with this document camera. I like 8. 8 is a factor of 16. Cool. Let's break this thing apart. We have cube root of a negative 8 times the cube root of a 2. Cube root of negative 8 is a 2, a negative 2. And then don't forget, you can't, this one doesn't clean up nice. You can't take the cube root of a 2 very easily. So it just stays negative 2 cube roots of 2. Okay? Could I break down 16? By prime factoring? Sure. Here, maybe I'll do it on paper so that I don't have to worry about the glare. Let's try this. Okay? Can you see that? So we can break down the negative 16. I know it's negative. We'll talk about that later. So for now, you just kind of ignore the negative. 8 and 2, that's prime, that's not. 2 and 4, prime, not prime. 2 and 2, prime and prime. And yes, I did not forget about this negative. We're going to have to come back to that. So now we have the cube root of, I had 4 2's, didn't I? 1, 2, 3, 4. When it's cube root, we're looking for a pair, or not a pair, but a triplet, a trio. And since there's a trio, you take 1 out. So it comes out, leaving behind that. Oh, I know it's so hard when you guys can't see everything. There we go. So the 1, 2 came out, leaving behind the cube root of 2 there. And oh, because it was negative, boom. You got to remember to throw that negative on there in the end. So if you're going to do the prime factoring way and there's a negative involved, you're going to have to turn your brain on and really remember that negative. Okay, I know it's a lot. I don't know. I mean, I could keep going. I feel like I could do 10 more problems, but I don't want to make this a 40-minute video. You want to do what? Like, you want to do another one? Let's do a really big one and let's break it down prime factoring. Can we try that? Okay, let's do this one over here. Let's do 18. Let's do this and let's do it with prime factoring. So cube root of negative 320. So I'm going to break down 320 to 10. Oops, that's a 10 and 32. And that is a 2 and a 5. 32, 8 and 4. 4 and 2. 2 and 2. Okay, so I took the 8 into a 4 and 2 and the 4 into a 2 and 2. This 4 becomes 2 and 2. And I can't forget, there's really a negative sitting out there because it was really a negative 320. So now I'm going to list all these factors. I know you can't really see, gosh darn. I have 1, 2, 3, 4, 5, 6 2s and a 5. And because it's cube root, I'm looking for triplets. There's a triplet, and there's a triplet. That means I'm going to take a 2 out and another 2 out. So 2 comes out, and another 2 comes out, which really then makes a 4. Leaving behind that 5, and remembering that it's negative. So the answer is -4 cube roots of 5. Boom. If you wanted to do it their way, quote unquote, their way, you would have had to have known to use 64. 64 is a factor of 320. You could have done that. Yep. Either way, you're going to get the same answer. All right? If I'm being honest, I really like my way better. I like prime factoring for square roots and cube roots. Even using, their perfect cubes and their perfect squares, I think that's a lot of us wouldn't have thought that -320, one of the factors is -64. I mean, that might take you some time to figure out. So I know this is a longer video, and I know this is extra difficult because we're learning this remotely. Here's the deal. I'm not expecting mastery. I just want you to understand that these things exist. I want you to know that there are these things called cube roots, and I want you to know how to handle it if the number that you're looking at under the radical sign isn't a cute little number that has a nice little clean cube root, right? If it has to be something sloppy like this. Just be aware that these things exist. Experiment with your calculator. Make sure you know how to use those radical buttons, okay? Thank you for watching. I miss you so much. I wish you nothing but the best. And I'll catch up with you soon, okay, guys? All right. Bye-bye.